Hi, my name is Arlene, and this is my second interview video for Breakthrough Collaborative at the Cincinnati site. And today I'll be teaching a science lesson to middle school students. Today our topic of discussion is symmetry and how the body truly isn't symmetrical. For example, the brain. The brain is divided into two hemispheres this way, and the left and right have different areas that control different functions. So say you see Ben here walking across the street and you recognize them. That face recognition is in the right hemisphere of the brain, that processing. So you go up to Ben and you want to say hi, and that language and speech patterns, those are in the left hemisphere of the brain. And also, another thing with symmetry is handedness. So for humans, there's usually a hand that's dominant over the other. When you're writing, people are naturally more comfortable writing with one hand over the other. So today, we're going to make an experiment looking at reaction time and how it corresponds to handedness. For people that are right-handed, is their reaction time with their right hand faster than their reaction time with their left hand? Reaction time is the time between a stimulus and a response. So, if you're sitting there playing a video game like Mario Kart or something, the stimulus is when the light turns green. And then your response is to press A button to make you go. So the reaction time is the difference between that light going off and you pressing the button. Also in real life, if you're driving and the stoplight turns red, that serves as stimulus. And then you react and you hit the brakes. So that is your reaction, your response. So today, we're going to look at reaction time with handedness. So when scientists do an experiment, they need to establish a procedure, which is a detailed step-by-step description of what they're going to do. So it's very important that your procedure be very detailed because you want it to make it replicable. So if someone far away, like some scientist in Sweden wants to do the same experiment, they should be able to do it following your description. And it shouldn't matter like their location or certain conditions. If they have the materials and if they can follow your procedure, they should be able to do it and theoretically get similar results. We're going to write a procedure for this dominance reaction time thing. So do you guys have any suggestions? What kind of thing what we can do to test reaction time? Have you guys ever heard of with a ruler? Using a ruler? Yes, Peter?
What you could do is you could put your hand like this on the 0 centimeter, and then you can drop it like that.
Okay, that's very good. That's a good idea. Do you guys see some problems with that potentially? Because you are the person dropping it and catching it. Yes,
There's no outside stimulus because the stimulus is you letting go, so you have...
Right. Good. Perfect. Yeah, like we saw with the Mario Kart and the stoplight, you need an outside stimulus. Something you can't expect. So it really gets your true reaction time. So, what can we do, guys, to correct this procedure? Chelsea?
We could have someone else hold the roller, so the person who's going to catch the roller doesn't know when it's going to come.
Excellent. Okay. That's good. Do you guys want to try it out? Can I get two people up here? Peter? And Rohan, come on up. Okay.
Yeah.
What Peter's going to do... Okay, Rohan hold the ruler. Peter, have his thumb hover at the 0 mark. And then Rohan can drop it whenever he feels like it. And then Peter will catch it. And so where his thumb lands will serve as a representation of the reaction time. So right now he's at about 17 centimeters. For example, if he landed on the 30, he's on the slower end. And if he landed 4 or 5 or something, that's really fast. So these numbers can quantify our data. Quantify as in putting our results into numbers. And this is really important because then you can analyze your results and calculate things to find averages. It's always beneficial to quantify your data in science. So, do you want to do it again with your left hand? Okay, well good. Now, here we have at the 12 centimeter mark. So good job. Okay, right hand can be 17, left hand can be 12. That'll be our data, and then we can draw our conclusions from there. Is that a good idea, class?
No, because we should have one either.
Right.
We don't know if that was an outlier.
Yeah, that's a good point. An outlier. So if one of our data points is just way off from the other one. So that's the importance of having something that is replicable. So having something that you can repeat and have it reproduce, like be able to reproduce it and do lots of trials. That's very important for a procedure. so now, okay, can you guys repeat the procedure that we just wrote, or came up with? Okay, go ahead. Thanks, Chelsea. Okay, so remember guys, we want to make this as descriptive and detailed as possible so that our Swedish scientists can reproduce it somewhere else. Okay, so what was the first step? Do you guys remember?
Somebody holding the ruler.
Okay, good. So have someone hold the ruler with, does it matter like the orientation, like how it's directed?
Has to be this way.
Okay, so vertically. So have someone, person A, hold the ruler vertically. Okay, good. And then the other person, have person B, what do they do? What does Peter do?
They should have their thumb hover around the 0 mark.
Yeah, good. So have person B have their thumb hover around the 0 mark. Have person B have his or her thumb hover, do you want to say right below the 0 mark of the centimeter line? On the centimeter side? Okay, that sounds good. Do you guys remember what happened next?
Then person A just drops the ruler without telling person B when they're going to.
Okay, excellent. It's very important that you emphasize they don't tell them when they do it. Because then that really serves as a representation of your true reaction. So right now we have person A will drop the ruler without telling person B. And then what, guys?
You record the centimeter that person A did.
Right, okay. So we're going to have person B catch the ruler and record where his thumb landed, his or her thumb. What should our last step be so that we can emphasize how it needs to be reproduced and replicated?
You repeat it with the other hand.
Yeah. So repeat steps 1 through 4 with the other hand. And then you can just say, repeat however many trials you want to. Okay, so good job guys. You have created a procedure, a detailed step-by-step description of testing handedness and reaction time. And if you wanted, you could actually do this and see whether your right or left hand was significantly faster or slower. And this is good because now it's replicable and our Swedish scientists can go do it. Thanks guys.